All right, we are on page 16, and you should have already filled out these table of values that are covered up in green. The point of today's video is to graph each of these equations using the slope and the y-intercept and not need to actually plot the points in the table of values. So in this video, I'm going to be walking you through how to identify the slope and the y-intercept and graph using only those two things, okay? Now, you've already filled out the table of values for 1 and 2, and you should see here that you have a straight line for both of these. And your straight line is going to be this right here, and your points should be here, here, and here. And of course, you connected the dots to make a straight line. Now, my goal is to teach you how to do that without needing this table of values. So the first thing you're going to do is you're going to identify the slope as a fraction and the y-intercept then as an ordered pair. Now I want to remind you guys up here that the slope, the steepness of the line, it is the coefficient of x right here in yellow. So in our first equation, the coefficient of x is this 1. So we're going to write that as a fraction, 1 over 1. All right. The next thing we're going to do is identify the y-intercept, which is the constant, and that's going to be this number here. And so the constant in this case is the 4, and we're going to write this as an ordered pair, 0, 4. So the constant, what that does is this moves the parent graph up. So we're going to start here at 1, 2, 3, 4. We know that this is going to be a point on the line. If I plug in 0, if my input is 0, the output here will definitely be a 4. So this is definitely going to be on the line right here on the y-axis. Now, using this rate of change, 1 over 1, I can simply increase by 1 here, while this increases by 1 on the x-axis, and plot a point, increase by 1 over 1, and so on. Now, I wanted to throw this out there, that if you take a -1 and divide it by a -1, that is a positive overall value. So in blue, you can see here that I have the option to move down 1 and back 1 and down 1 and back 1, and those points fall right in line with the line that you graphed for number 1 for y equals x plus 4. All right, let me just straighten that up a bit. Friendly reminder that when you graph using your ruler that you should put arrows on the end. And so we have now graphed the 1x plus 4 right here. Now in the second one, our slope, so the coefficient is a 1, and as a fraction that's going to be 1 over 1. That's our rate of change, 1 over 1. Now this one, if we were to plug in a 0 right here, 1 times 0 is 0, and then we'd get a 2. So the place where it crosses the y-axis, our input is going to be 0 and the output is 2. So we're going to start this one at 0, 2. Then we'll continue to build that staircase in the background, rise over, run, the up and over. So up and over, this is our rate of change, up and over, okay? Now, same thing holds true. You can move down and back. So I can move down and back 1, down and back 1. And you can see here that I have now graphed the exact same line that you had. I didn't need any ordered pairs to graph the line. Notice that the table of values is covered up here in green. So we do not need the table of values to graph the line. I'm currently teaching you how to use the constant and get that starting point, and then use the coefficient, the rate of change in the background, okay? So now let's take a look at how these proportional graphs are going to be a little bit different. You might remember that graphs 1 and 2, these are additive because we have that constant, and that constant simply moves the line up or down on the y-axis. Now here, when we have our proportional graph for y equals 3x, I'm going to first start out by identifying the coefficient. The coefficient here is 3. So as a fraction, that is 3 over 1. Okay, that's our coefficient. And it says it up top here that the slope is your coefficient. So that's our slope. And now let me ask you guys, what is this plus b? Well, if you don't have a constant, that's going to be 0. And so if we were to plug in a 0 here, 3 times 0 is 0, and then we don't add anything, so we're left with 0 as our output. And so you might remember here that these equations are going to be passing through the origin at 0, 0. So this time our 0, 0 origin is our starting point, and now we're going to use the 3 over 1. So this rate of change is up 3 over 1, up 3 over 1. You might remember our gym problem where we talked about $3 per visit or $2 per visit or $1 per visit. So this shows that it's $3 more each time you go. $3 more each time you go. Now, this is not a word problem, so I could plug in negative values, and the same holds true if I do a -3 divided by a -1. 1, 2, 3, back 1, 1, 2, 3, back 1. And so now this should be the exact same line that you had graphed on your coordinate plane when you used the table of values. All right. And so now for this last one, first thing we're going to do is identify our coefficient, the slope. That's the 1/2. And once again, since we don't have a constant, we know that this is going to pass through the origin at 0, 0. Okay? So we're going to start this one at 0, 0. It's going to pass through the origin, and then we use the red number to build the rest of the points. So this would be like the gym problem where we said it was $1 every 2 times you go, which would be 50 cents per trip to the gym. That might sound familiar. But we can use the $1 every 2 visits to say, okay, so $1 every 2 visits. $1 every 2 visits. Same thing holds true when you take a negative and divide it by a negative. This is still overall a positive value. So I can move down 1 and back 2, and then down 1 and back 2, and that still is a positive 1/2. And once again, we can see now that this matches up, and that is the exact same line that you had using the input-output table of values. All right? So the purpose of this video was to go through and to teach you how to identify from an equation that's in this form 2 things. You want to identify the slope and the y-intercept. That's why it's called slope-intercept form. So your coefficient here, that's going to be your slope. And this constant is the y-intercept where the line crosses the y-axis, and this is written as an ordered pair. All right? So now I'm going to just have down here, I want to just practice one with you guys. So we've got 1, 2, 3, 4 equations that we're going to graph real quick, and I'm just going to practice this with you to make sure you got the hang of it. This is not in your notes. There's nowhere for you to take notes with me. I just want you to watch to make sure you're getting the hang of this, okay? So for this first one, our coefficient is a 2, and as a fraction, that'd be a 2/1. For this next one, our coefficient here is a 1, so as a fraction, that'd be a 1/1. For this blue one, our coefficient is a 1/3. And for this green one, our coefficient is a 1, so I'm going to put 1/1. All right? So that's the first part. You're just identifying the slope. Now, the next part, as an ordered pair, you want to identify the constant. Now, in this first one, the constant would be 0, so this one's going to pass through the origin. In the red one, it's a constant of -4, so this one's going to pass through 0, -4. Again, when you plug in 0, you get a -4, and these points are always on the y-axis. We've talked about that. When your input is 0, it's going to be on the y-axis, all right? That's why it's called the y-intercept. We know it's going to cross the y-axis. All right, now for the blue one, there is no plus or minus number, so this one's going to cross at the origin. And for the green one here, the constant's a 5, so it'll cross. If you plug in a 0, the output would be a 5, okay? So now we're going to focus just on the first equation, and I'm going to graph this line here in black. We identified that it doesn't have a constant, so we're going to start here at the origin, and then we're going to use the rate of change, the 2/1. So this was up 2/1, up 2/1, up 2/1, and when I connect, this is going to be the first line I wanted to review with you guys. There's the black line, okay? Now, another thing I wanted to point out was that if the values were to be negative, negative, I could move down 2 and back 1. That falls in line. Down 2 and back 1, and so it still falls in line. And a negative, negative is still overall a positive value. So that takes care of our first line, okay? Now I'm going to review with you guys how to do this one here in red. So for this one, we said that because the constant's a -4, this one this time is going to start down here at the -4. And we're going to use our rate of change, the coefficient of 1/1. So 1/1, 1/1, 1/1. And of course, because a negative divided by a negative is still positive, I could move back, down and back. And this is down 1 and back 1. And here is the red equation graphed on the coordinate plane. Notice I'm just trying to review with you guys how to take the constant and use that as the starting point, and then use the coefficient as the rate of change to build the rest of the numbers, the rest of the points, I should say. All right, now we're on this blue one, so it's a 1/3 x. Because there's no constant, it should pass through the origin. So here's this one in blue. And now we're going to use the rate of change up 1 over 3, up 1 over 3. So up 1 over 3, up 1 over 3. And of course, because a negative divided by a negative is still positive, I could move back 1, down 1 I should say, and back 3, down 1, and back 3. Notice that the rate of change up 1 over 3 still works if I go up 1 over 3, up 1 over 3, up 1 over 3. So it'll work this way with these points as well. And this is what the blue line would look like on the coordinate plane if we were to have graphed it. I'm just graphing all of these equations on the same coordinate plane, and you can see here I do not have any tables of values, no input output numbers. This is us taking the training wheels off of our bike and learning how to graph these lines straight from the equation over here to the coordinate plane. So we have one final one to review here in green. So again, because this constant was a 5, this one, if you plug in a 0, it's going to have an output of 5. So this one's going to start up here at 0, 5. And then the rate of change, because the coefficient is 1, it's up 1 over 1. Now, because we're running out of room here, that's why we want to consider the fact that the negative divided by a negative is still a positive 1. So down and back, down and back, down and back. And this was the last line that I wanted to graph with you guys. There it is in green. And I do have a follow-up question for you now. 2 of these lines should be parallel. 2 of the lines on this graph are parallel, and I'm going to highlight them now so that they stand out. This line is parallel to this line. The red line and the green line were parallel. Oops, not that one. So here was the red line, and this was the green line. And I wanted to point out here that they're parallel because they have the same rate of change. This rate of change is the same as this one, so that's why the up 1 over 1 is the same, and these lines are parallel. Now between the blue line and the black line here, I just want to point out that our black line is steeper because this is a higher rate of change than the 1/3. 2 is bigger than 1/3. And because 2 is bigger than 1/3, we know that this line should be steeper. And that concludes your video on page 16. Thank you.